Are there boundaries in this world we cannot cross? Is there a place we could never reach, no matter how hard we try? In fact, such limitations do exist. Even with the technology of science fiction, we remain trapped within a cosmic pocket. Why is this so? And just how far can we truly go? We live in a quiet spiral arm of the Milky Way, an average-sized spiral galaxy about 100,000 light years wide, containing hundreds of billions of stars, gas clouds, dark matter, black holes, neutron stars, and planets. At the galaxy's center lies a supermassive black hole. From a distance, our galaxy appears incredibly dense, but in reality it consists mostly of empty space. With our current technology, sending humans to the nearest star would take thousands of years. Thus, our Milky Way is quite large, yet it is not alone. The Milky Way, along with the Andromeda Galaxy and over 50 dwarf galaxies, forms part of the so-called local group, a region of space over 10 million light years in diameter. It is one of hundreds of galaxy groups within the Laniakea supercluster. Millions of similar superclusters make up the observable universe as we currently know it. Now, suppose we have a bright future. Humanity evolves into a Type 3 civilization, avoids annihilation by alien invaders, and develops interstellar travel based on our current understanding of physics. In this best-case scenario, just how far could we actually go? The answer is still within the local group. This is the largest structure humanity could ever engage with. Though vast, the local group comprises only 0.000000001% of the observable universe. Let's contemplate that number. We are confined to 100 billionth of the observable cosmos. The realization that a tangible boundary limits us, that we can never venture beyond it, is profoundly unsettling. Why can't we go beyond? It all relates to the vacuum of the universe. The cosmic vacuum isn't truly empty. It possesses its own energy known as quantum fluctuations. On a microscopic scale, the vacuum is in constant motion, with particles and antiparticles continuously being created and annihilated. Imagine this quantum vacuum as a container filled with bubbles, denser regions, and less dense areas. Now, let's go back over 13.8 billion years. When the universe was composed of this void, after the so-called Big Bang due to a phenomenon called cosmic inflation, the observable universe expanded from the size of a pinhead to trillions of kilometers in just a fraction of a second. This sudden cosmic stretching occurred so rapidly and extremely that all these quantum fluctuations were similarly stretched, transforming the initial subatomic distances into present-day galactic scale distances, filled with dense regions and less dense regions. After the expansion, gravity began pulling everything back together. From a macro perspective, gravity cannot hold everything together, but on smaller scales, it still prevails. Thus, over time, denser regions, or cosmic pockets, grew into galaxy clusters, much like the where we now reside. Everything within the local group is held together by gravity. So what is the problem? Why can't we travel from our pocket to another? It is all because dark energy complicates matters. About 6 billion years ago, the universe began filling with dark energy. Essentially, dark energy is an invisible force and phenomenon that drives and accelerates cosmic expansion. We don't know why or what dark energy is, but we can clearly observe its effects. In the early universe, the local group contained larger cold spots that later grew into thousands of galaxy clusters. We are surrounded by many things, but no structure or galaxy outside our local group is drawn by its gravity. So the more the universe expands, the greater the distance between different groups becomes. So the more the universe expands, the greater the distances become between different groups. Over time, dark energy isolates us within the universe, eventually rendering us inaccessible to other clusters, galaxies, and groups. The next galaxy group is already millions of light years away, yet they all recede from us at speeds we can scarcely imagine. We could leave the local group and attempt to fly through intergalactic space, but in the darkness, we would never reach anywhere. In the cosmos, we grow increasingly isolated. While within the local group, objects will grow closer together, merging into a massive elliptical galaxy called Milkdromeda over billions of years. But what follows is even more disheartening. In the foreseeable future, the stars beyond the local group will be so distant that they become undetectable, as only a minuscule fraction of photons will reach us. The wavelengths of those photons will stretch beyond detectable limits. Once this occurs, no information about the local group from beyond will ever reach us. The universe will vanish from view. It will appear dark and empty from every perspective. Forever. Future Milkdromeda inhabitants will believe their own galaxy stands alone in the cosmos. When gazing into the void, they will see only more emptiness and darkness. They will be unable to detect the cosmic background radiation, unable to know the Big Bang ever occurred. They would have no way of knowing what we know today, the expansion properties of the universe, its beginning and its end. They would believe the universe to be static and eternal. Milkdromeda would be an island in darkness, slowly growing ever darker. Yet even so, the local group would still contain trillions of stars, enough to be vast for humanity. After all, we still haven't figured out how to leave our solar system, and we still have billions of years ahead to explore our galaxy. We are incredibly fortunate to exist at this moment, for we can not only see our future, but also peer into the most distant past. Even within the isolated local group, we can still perceive the current grandeur and magnificence of the entire universe. His astronomy blog is here. You can support us directly on Patreon or get Kurzgesagt merchandise here. Both help us tremendously. You've come this far, so we've created a playlist for you about even more cosmic wonders.